Okay, welcome back to Mathematics by AC Okocha, and today I'm going to be taking this partial fraction series to the last stage. What I want you to do is to attempt as many questions as you can. If you have any issue, you can send it across. Now, there is what is called improper fraction. I said I'll be showing you improper fraction today. This is one of the way improper fraction can be presented. How do you know an improper fraction? An improper fraction is that one such that the power down and the power up is either the same or the power up is greater than the power down, or rather the power down. What am I saying? Yes, the power up is greater than the power down. We call it improper fraction. For instance, normal typical improper fraction, 5 over 2. 5 over 2 is an example of an improper fraction. So when you have an algebraic expression such that the degree up is bigger than the degree down, then that one is an improper fraction. Or if they have the same power, like this is 2s raised to the power of 2, this s raised to the power of 2. So this is a good example of improper fraction. Are you following? This is an improper fraction. So when you have an improper fraction, what do? Before you split it, or before you can be able to split it into partial fraction, you have to first of all bring out the whole number part. It's just like the way you have 5 over 2. 5 divided by 2 will give you 2 whole number, 1 over 2. So that whole number part, we need to bring it out here so that we can now be able to split the other part into partial fraction. And for us to be able to bring out the whole number part, we are going to apply the knowledge of what? Polynomial. Remember that this is what we have. This is what we have, that 2s squared plus 1 over s squared plus s. If we use polynomial to solve this, let's use polynomial to solve this. What does this imply in terms of polynomial? Let's use long division, of course. So here we have s squared plus s. Here we have this is dividing 2s squared. Since there is no s, let's leave space. Then we'll put plus s here, plus 1 here rather. Now watch this. S squared going into 2s squared. That will give me 2. 2 times s squared, 2s squared. 2 times s plus 2s. So we introduce the elimination sign here. And what do we have left? This will cancel out. Plus 2s squared minus 2s squared is 0. Minus times plus. Here is minus 2s. Then what? Plus 1. Are you there now? Now, do you know the implication of this? Let me show you what this means. This expression here can now be rewritten as 2s squared plus 1 over s squared plus x equals to the quotient plus, what is the remainder? I can start with 1. Let me start with 1 to avoid this minus. 1 minus 2s, then over the divisor, s squared plus s. If you solve this side now, this is what it will give you. Are you seeing it now? If you solve only this side, it will give you this. So what are you now to do? It is this one now that you will now split into partial fraction and put it back here before you present your answer. It is only this one that you will split into partial fraction. So let's split only this one into partial fraction. So this is 1 minus 2x over s squared plus x, which is the same thing as, let's rewrite it as 1 minus 2s. If we factor s outside, what will remain? It will remain s plus 1. Then you know what we'll do with this now. We've done it. That is our first class. So this one means that a over what? X plus b over what? X plus 1. So from here, 1 minus 2x over s bracket s plus 1 is equal to, when you find the LCM here, we'll get s bracket s plus 1. This to this will give us this times a times s plus 1 plus this to this, s plus 1 will cancel s plus 1, remaining s times b, bs or b times x. I told you that the denominator is the same, so they will cancel out. We're left with 1 minus 2x is equal to a times s plus 1, then b times x. So you know what we have to do now. We'll remove a, cover up a to find b, put s is equals to minus 1. So if we do that, we'll put s is equals to minus 1 to find b. Let's do that to find b. So we have 1 minus 2 minus 1. Anywhere you see s, you put minus 1. If you put minus 1 here, a is 0, so a is out. Put minus 1 here, I have b times minus 1. And b times minus 1 is minus b. Minus b come to the left-hand side, they become plus b is equals to minus 2 times 1 plus 2. 2 plus 1, 3. 3 come to this side, will give you what? Minus 3. So this is the value of b. Let's go for a. To find a, we can just put that s is equals to 0. If we put that s is equals to 0 to find a, so from here again, 1 minus 2 times 0 is equals to a bracket 0 plus 1. Because when here is 0, 0 times b will give us 0. So this will give us 2 minus 2 times 0, 0. So here is 1 remaining here, equals to what? 0 plus 1, 1, a. So that means that a is equals to 1. Is that clear? So therefore, look at how we present the final answer now. Remember the original expression. Let's start with that. Therefore, 2s squared plus 1, s squared plus 1 is equals to, you first of all write this 2. 2 plus, then you see this one that will split into partial fraction, that is this 2. What is a? A is 1. That is 1 over x plus b. What is b? B is minus 3. Since b is minus 3, here cannot be plus again. Here cannot be plus. Since b is minus 3, here cannot be plus. So here has to be minus. Over 3 over what? What is the x plus 1? So this side now is the solution, or is a partial fraction of this part. Now, how do you know if it's correct? Just go and solve for only this side. If you solve for only this side, this is what you will arrive at. That is the best way to confirm your answer. So this is how to solve for improper fraction. So anytime you have an improper fraction, you must first of all get the quotient and leave it. Then it is the remainder over the divisor, this one. Because this plus this over this will give you this. It is this one that you will now split into partial fraction before you cannot be able to present your values. Does that make sense? Okay, so there are different styles. This one may even be a bit simple. There are some that are more sophisticated, but it's the same principle. You are not cramming it. It's just for you to understand the principle. When you understand the principle, you should be able to solve any one that you meet. So that will be it. So in case you have any question or any confusion, you can always post it in the community. People will attend to it, or I will also attend to it. Thank you, and see you in our next class tomorrow.